Good morning, students. Once again, I welcome you to my GATE class. I'm continuing with the 2019 EE paper, Electrical and Electronics paper. This problem is based on theorem, network theorem. The current I flowing in the circuit shown in ampere is dash. So this is the network. So I is the current through 2 ohms. So we have to find this value I. Now, for a student, as soon as he sees this problem, he is tempted to use Thevenin theorem. But Thevenin theorem is not permissible in this problem. You know the procedure of Thevenin theorem. So in Thevenin theorem, we used to divide or break the original network into two, network A, network B. For example, you have to find current through 2 ohms. So that is taken as one part. The remaining network becomes network A. So it is like this. So this is network A. This is network A. This is network A. Network B is this. If you call these two terminals as X, Y, this is network B. Network B. So in this problem, there is a dependent source. So current controlled voltage source is there. So 5i is the value. So this source is being controlled by I. If you break the circuit like this to apply Thevenin theorem, then I is in network B, whereas the one which is going to be controlled by I is in another network. So that is not permissible. So you are not, both controlling quantity and the dependent source must be in the same network. Then only you can apply Thevenin theorem. Otherwise you can't apply Thevenin theorem to this problem. Therefore, inevitably you have to go for any other theorems. For example, superposition theorem. Superposition theorem is permissible. Now I will apply this because this is a multi-source circuit. For 20 volt source, 2 ampere source. So more than one source is there. So I can apply superposition theorem. Now I will solve this problem by applying superposition theorem. So in superposition theorem, one source is considered at a time. Now first I will consider this 20 volt source. 20 volt source. Now I will call this current as I1. This current as I1. Then this becomes 5I1. Now apply KVL. Apply KVL. On applying KVL, this is 2I1. This is 3I1 plus 5I1 I1 minus 20 equal to 0, or 10I1 is equal to 20, or I1 equal to 2 amperes. I1 equals 2 amperes. Next is, now I consider 2 amp source. I will consider 2 amp source. I will consider 2 amp source and I will short this 20 volt source. And I will call this current as I2. I1, I2. Now this becomes 5I2. Now I2 is flowing like this, 2 amperes is like this, therefore this current is I2 plus 2 plus I2. Apply KVL to this path. Apply KVL to this path. 3 into 2 plus I2 plus in going from plus to minus, fall in potential taken with plus sign, 5I2. Then here plus 2I2 equal to 0. Here 2I2. Simplifying, 6 plus 3I2 plus 7I2 equal to 0, or 10I2 is equal to minus 6, or I2 is equal to minus 0.6 amperes. Minus 0.6 amperes. Now apply superposition theorem. Therefore, what is I then? I is equal to I1 plus I2. I1 is 2 amperes. I2 is minus 0.6 amperes. Therefore, answer is 1.4 amperes. 1.4 amperes. So, this is how you have to work out this problem. So, keep it in mind once again. I will stress this point. So, Thevenin theorem cannot be applied to this problem. Thank you.